All right, let's talk about something you've probably seen but never really thought about: the power contactor. We're calling it the unsung hero of automation for a really good reason. It's the secret to how we get some of the biggest, baddest machines to work with just a tiny bit of electricity. So let's get right to the big question. How in the world do you safely control a giant motor? I'm talking something huge with just a tiny little button. You've got this massive force on one side and this teensy little electrical signal on the other. How do you even make that work? Yeah, that's what we call the high power problem. It's all about bridging that massive gap between those small, delicate signals and the huge raw force needed to get things done. Think about it like this. You have the brains of the operation, right? Like a computer or a PLC. It's super smart, but it speaks in whispers, these tiny, safe electrical signals. Then you have the muscle, the giant motor, the industrial heater. That thing needs a ton of power, a real electrical shout. You can't just hook them up directly. That would be a disaster. You need something in between, a sort of electrical translator or a heavy-duty middleman. And that's where our hero comes in. Say hello to the power contactor. This is the device that safely connects the brains to the brawn, making all this incredible automation actually work without, blowing up. So what exactly is it? Well, at its core, it's just a switch, but it's a really, really tough, heavy-duty switch. And here's the cool part. You don't flip it with your finger. It gets flipped on and off by a tiny, safe electrical signal. That's the whole secret sauce right there. That's what makes remote control possible. Okay, let's put this into perspective. A regular old light switch, you're physically connecting a high-power circuit. That's fine for a lamp, but for a giant industrial motor, no way. It's totally impractical and dangerous for automation. The power contactor, on the other hand, is a total game changer. It lets you control all that dangerous power from a safe distance, using a signal that's completely harmless. So, how does it actually work? It kind of seems like magic, right? How does this tiny little signal boss around such a massive amount of electricity? Well, it's not magic. It's just really clever physics. And it all comes down to a tiny magnet doing all the heavy lifting. Let's walk through what happens when you turn something on. First, that small, low-voltage control signal zips over to the contactor. Step 2, that signal energizes a little electromagnetic coil inside. Think of it like flipping a switch on a magnet. Instantly, a magnetic field pops into existence. And what does it do? It acts like a super strong invisible hand, and clack, it pulls a set of big, beefy metal contacts together. And boom, the high-power circuit is complete. The current starts flowing to the motor. Now, turning it off is just as important, and maybe even cooler. The moment you cut that small control signal, the electromagnet just turns off. The magnetic field vanishes. And a spring, which has been compressed and just waiting for its moment, goes spring and shoves those contacts apart. The high-power circuit is broken instantly. It's a simple, reliable, and incredibly fast way to cut the power safely. Okay, so that's how it works. Pretty neat, right? But now let's get into the why. Why is this little device so incredibly important? The truth is, this simple idea is the reason you find contactors pretty much everywhere, from a massive factory floor to the air conditioning system in a giant skyscraper. It all comes down to a few critical jobs that it does perfectly. First, and most obvious, is safety. It keeps people far away from dangerous high voltage. Second, it protects all that expensive machinery by being able to shut things down in a split second if something goes wrong. It also talks perfectly with the brains of the whole operation, the PLCs. And finally, it lets us do really complex stuff, like starting up a whole series of motors in a very specific order. It's the ultimate team player. Here's a perfect real-world example to tie it all together. Picture a huge conveyor belt in a factory. The main computer, the PLC, sends out a tiny, harmless 24-volt signal. That signal tells the power contactor, hey, it's time to go. The contactor then does the real work, switching on the massive motor that moves the belt. And it does this over and over and over again, thousands of times a day, perfectly and safely every single time. And that, right there, is why we call it the unsung hero. The power contactor is that absolutely crucial link. It's the bridge that connects the smart, digital world of computers to the raw, physical power needed to actually build things, move things, and get work done in the real world. Honestly, it's not an overstatement at all. Without the power contactor, our modern automated world would just stop. It is that essential, invisible workhorse, quietly sitting in a control cabinet, managing insane amounts of power with nothing more than a gentle electronic whisper. So, next time you're out and about and you see some big automated machine fire up all by itself, you'll know the secret. You'll know there's a little power contactor in there doing the heavy lifting. And that kind of makes you wonder, doesn't it? What other simple, brilliant, invisible bits of tech are hiding all around us, making our entire world run?